The Arctic, a vast and icy wilderness, is changing at an alarming rate. Once a symbol of unyielding cold and isolation, it is now a region undergoing rapid transformation. For centuries, this frozen ocean has captivated explorers and scientists alike. The allure of its uncharted territories and the mysteries hidden beneath its ice have driven countless expeditions. It is home to unique wildlife and plays a crucial role in regulating our planet's climate. The Arctic's delicate ecosystem supports a variety of species, from the majestic polar bear to the resilient Arctic fox, each adapted to survive in this harsh environment. However, a chilling warning from scientists has sent shockwaves around the world. The Arctic could be ice-free by 2027. This stark prediction highlights the urgency of addressing climate change. This prediction, based on extensive research and computer simulations, paints a stark picture of the future of this vital ecosystem. The data is clear. The ice is melting faster than ever before, and the consequences are dire. The Arctic sea ice, a thin layer of frozen seawater that forms and melts with the changing seasons, is shrinking at an unprecedented rate. This seasonal ice, once a reliable feature of the Arctic landscape, is now becoming increasingly unpredictable. This ice is not just a frozen wasteland, it is a vital component of the Earth's climate system. Ice cores reveal a history of our planet's climate, providing invaluable data for scientists. It reflects sunlight back into space, helping to regulate global temperatures. This albedo effect is crucial in maintaining the Earth's energy balance. Its disappearance would have far-reaching consequences for our planet, impacting weather patterns, wildlife, and even our own way of life. The loss of sea ice could lead to more extreme weather events, affecting communities far beyond the Arctic Circle. The potential for an ice-free Arctic within the next few years is a stark reminder of the urgent need for action on climate change. It is a call to policymakers and individuals alike to take meaningful steps to reduce greenhouse gas emissions. It is a call to protect this fragile ecosystem and the countless species that depend on it. The survival of iconic Arctic animals, such as polar bears and seals, hangs in the balance. We must act now to preserve the Arctic for future generations. Community efforts and individual actions can make a difference, from reducing carbon footprints to supporting conservation initiatives. The interconnectedness of our planet means that what happens in the Arctic does not stay in the Arctic. Melting ice contributes to rising sea levels, which threaten coastal communities around the world. The consequences of a warming Arctic will be felt globally, underscoring the need for a united global effort to combat climate change. International cooperation is essential to address this crisis effectively. The time for complacency is long gone. The future of the Arctic, and indeed our planet, depends on the choices we make today. Every action counts, and together, we can work towards a sustainable future for all. The Arctic is warming at twice the rate of the rest of the planet, a phenomenon known as Arctic amplification. This rapid warming is primarily driven by human activities, particularly the burning of fossil fuels, which release greenhouse gases into the atmosphere. These gases trap heat, causing the planet to warm. The impacts of this warming are already being felt across the Arctic. The extent of summer sea ice has declined dramatically in recent decades, reaching record lows in recent years. Satellite images show a shrinking ice cap, with vast areas of open water where once there was only ice. This decline in sea ice has profound implications for the Arctic ecosystem. Ice-dependent species such as polar bears, walruses, and seals rely on the ice for hunting, breeding, and resting. As the ice disappears, so too do their hunting grounds and the habitats they need to survive. The melting of permafrost, a layer of permanently frozen ground that underlies much of the Arctic, is another alarming consequence of warming temperatures. Permafrost stores vast amounts of carbon, which is released into the atmosphere as it thaws, further accelerating climate change. Scientists use a variety of methods to study and predict changes in Arctic sea ice. They analyze satellite data, collect ice cores, and conduct field research in some of the most remote and challenging environments on Earth. These ice cores, which are long cylinders of ice drilled from glaciers and ice sheets, contain layers of snow and ice that have built up over thousands of years. By examining these layers, scientists can learn about past climate conditions and how they have changed over time. In addition to ice cores, scientists deploy buoys to monitor ice thickness and movement. These buoys are equipped with sensors that measure various parameters, such as temperature, salinity, and ice thickness. They transmit data in real time, providing continuous monitoring of the Arctic ice conditions. These observations provide valuable insights into the current state of the Arctic and how it is changing over time. The data collected from satellites, ice cores, and buoys help scientists understand the complex interactions between the atmosphere, ocean, and ice. This understanding is crucial for predicting future changes in the Arctic and their potential impacts on global climate. To project future changes in sea ice, scientists rely on sophisticated computer models, known as climate models. These models are mathematical representations of the Earth's climate system, incorporating data from various sources to simulate how the climate behaves under different conditions. These models simulate the Earth's climate system, including the atmosphere, oceans, ice, and land. They allow scientists to test different scenarios and see how changes in one part of the system might affect the others. For example, they can simulate how increasing greenhouse gas emissions might lead to higher temperatures and more rapid ice melt. By inputting different scenarios for future greenhouse gas emissions, scientists can explore a range of possible outcomes for the Arctic. They can test how different levels of emissions might affect ice thickness, extent, and seasonal patterns. This helps policymakers understand the potential consequences of their decisions and the importance of reducing emissions to mitigate climate change. One recent study, which used over 300 computer simulations, found that the Arctic could be ice-free in the summer as early as the 2030s. This means that, within a few decades, we could see a dramatic reduction in Arctic sea ice, with significant implications for global climate, sea levels, and ecosystems. This alarming finding highlights the urgency of addressing climate change and reducing greenhouse gas emissions. The loss of Arctic sea ice not only affects the region's wildlife and indigenous communities, but also has far-reaching impacts on global weather patterns and sea levels. These simulations are not just theoretical exercises, they are based on real-world data and the best understanding of climate science. The models are continually refined and updated as new data becomes available, ensuring that they provide the most accurate predictions possible. While there is always some uncertainty in any prediction, the overwhelming consensus among scientists is that the Arctic is on a trajectory towards an ice-free state. This consensus is based on multiple lines of evidence, including observational data, climate models, and historical records. Human activities, such as burning fossil fuels, deforestation, and industrial processes, are the primary drivers of this change. These activities release large amounts of greenhouse gases into the atmosphere, trapping heat and causing the planet to warm. Reducing these emissions is critical to slowing the rate of Arctic ice loss and mitigating the impacts of climate change on a global scale. Section 4. A world without ice implications for weather and wildlife. An ice-free Arctic would have profound consequences for weather patterns and wildlife, both within the Arctic and beyond. The loss of sea ice would disrupt the jet stream, a band of strong winds that circles the northern hemisphere. This disruption could lead to more extreme weather events, such as heat waves, droughts, floods, and severe storms in North America, Europe, and Asia. The Arctic ecosystem is finely balanced and highly vulnerable to change. The loss of sea ice would have cascading effects throughout the food web, impacting everything from microscopic algae to top predators like polar bears. As sea ice disappears, so too do the hunting grounds for ice-dependent species like polar bears, walruses, and seals. These animals rely on the ice to hunt, breed, and raise their young. Without ice, their populations are at risk of decline or even extinction. The warming Arctic is also opening up new shipping routes and opportunities for resource extraction, potentially leading to increased human activity in the region. This increased activity could have further negative impacts on the fragile Arctic environment. Section 5. The Melting Paradox. Why sea ice loss doesn't flood our coasts. It might seem counterintuitive, but the melting of Arctic sea ice does not directly contribute to sea level rise. This is a common misconception that needs to be clarified to understand the broader impacts of climate change. This is because the ice is already floating in the ocean, and its volume is already accounted for in the overall water level. When sea ice melts, it simply transitions from a solid state to a liquid state without adding extra volume to the ocean. Think of an ice cube floating in a glass of water. As the ice melts, the water level in the glass doesn't change. This principle, known as Archimedes' principle, explains why floating ice doesn't affect sea levels. However, The melting of land-based ice, such as glaciers and ice sheets in Greenland and Antarctica, does contribute to sea level rise. This is because these ice masses are situated on land, and when they melt, the water flows into the ocean, adding to its volume. This is because the water stored in these ice masses is not already in the ocean. When it melts, it introduces new water into the ocean system, leading to an increase in sea levels. As these glaciers and ice sheets melt, they add new water to the ocean, causing sea levels to rise. This process is a significant contributor to the observed rise in global sea levels over the past century. While the melting of Arctic sea ice doesn't directly raise sea levels, it does have indirect effects that contribute to the problem. One of the most significant indirect effects is the albedo effect. The loss of sea ice exposes darker ocean water, which absorbs more heat from the sun than reflective ice. This change in surface reflectivity leads to increased heat absorption, further warming the Arctic region. This increased heat absorption further warms the Arctic, accelerating the melting of land-based ice and contributing to sea level rise. The warming Arctic also affects weather patterns and can lead to more extreme weather events globally. The melting of Arctic sea ice is a symptom of a much larger problem: global climate change. The changes in the Arctic are a clear indicator of the rapid pace of climate change and its far-reaching impacts. While it may not directly flood our coasts, it is a stark reminder of the interconnectedness of our planet and the consequences of our actions. The health of the Arctic is closely linked to the health of the entire planet, and the changes we see there are a warning of the broader impacts of climate change. Addressing the root causes of climate change, such as reducing greenhouse gas emissions and transitioning to renewable energy sources, is crucial in mitigating these impacts. The actions we take today will determine the future health of our planet and the stability of our coastal regions. Communities around the world are already taking steps to adapt to rising sea levels and protect their coastlines. Innovative solutions and collective efforts are essential in building resilience against the ongoing and future impacts of climate change. By understanding the science behind sea ice loss and its broader implications, we can make informed decisions and take meaningful actions to safeguard our environment for future generations. Together, we can work towards a more sustainable